Hey guys, so today we're going to talk about what is light? What is light and what is color? They're electromagnetic waves. Are you guys ready? Let's go! Light is the fastest thing in the known universe. It can go 186,282 miles per second. If you were going the speed of light, you could fly around the earth 7.5 times per second. Whoa, that's a lot of flying. So what if you could only see one color? Only one color was visible to you. Look around right now. The only color you can see is green. Everything else would be invisible. How many things would you walk into? A lot. That's right. So usually when we're talking about light, we're talking about visible light. Visible light, right? So there's a very small spectrum for that. But you guys have something amazing. You guys have electromagnetic wave sensors in the room with you right now. You too. Believe it or not, you do. You have these sensors right there. Guess what they are? That's right. They're your eyes. So the first thing we have to talk about is what goes to your eyes. Well, your eyes can only see that small little part. You see right there? That's visible light. So visible light goes from everywhere from 400 nanometers all the way to 700 nanometers. That's all you can see, but it's a spectrum all the way from violet to red. And that's why whenever you see a rainbow, it's like that. It's in order of the slowest wavelength that your eyes can see all the way to the fastest. By the way, that's always made me ask this question. Why is Flash Gordon's suit red? That's the slowest wavelength that we can see with our eyes. It's like 750 nanometers. Why would Flash Gordon be wearing the slowest wavelength? Why wouldn't Flash Gordon, be as fast as Flash Gordon is, be wearing like violet? So gamma rays we can't see, but you see the waves that go like that? That's right. And then there's X-rays, and then there's ultraviolet. Now, bees and butterflies can see those, and that helps them navigate their way around. And then we have visible light. And this is the light that excites your retina. We're gonna get back to that in just a moment. There's also infrared light. Snakes and mosquitoes can see infrared. How does that help them? That's right, it helps them be heat seekers. We don't see infrared naturally with our eyes. And then there's microwave. Those make our really good popcorn. Hey, let's go make some real quick. Okay, come back. There's also radio waves, TV, radar. Those get really, really slow down. With the wavelength, which is the space between one wave to the other wave, and that equals the energy. Well, the energy of that light tells how it will interact with matter, like the cells in our eyes. So you guys remember me telling you? Your eyes right here. You have them on you. They're electromagnetic wave sensors. Whoa! So the wavelengths go in, through your cornea, down to your lens, and it speaks right to your retina, where it has receptors. So there's rods that measure the bright, and there's cones that receive different colors, depending on the wave that goes in there. Will tell your brain what color you're seeing. So visible light is exciting your retina. So the color we're seeing with our eyes is the color that's bouncing off of them, the one that's not being absorbed. So white is really all of the colors that are reflecting visible light. It's bouncing them off, pushing them off, and black is absorbing all of the visible light. We see a leaf, it's absorbing all of the different colors except for green. That's right, you're seeing green because it's boo, 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 bouncing off of it. So that brings us to another big question. Why is the sky blue? Oh my gosh. Well, it has a little bit to do with 3 different things. It has to do with, again, what we were talking about is the wavelengths and the frequency, which we were just talking about, but it also has to do with something called atmosphere. And then again, it has to do with your eyes, your retina, your electromagnetic wave sensors. So nitrogen makes up about 80% of our atmosphere, and it's really lightweight. Oxygen is pretty lightweight too. If you see, it's pretty low on the periodic table, right? So it's pretty lightweight. So those really small wavelengths can just hit it, kind of like this, right? Boo, boo, boo. So those wavelengths are coming down, and they're really, really squiggly. See that? I'm gonna turn this around so you can see it. So the blue wavelengths, they're pretty tight, they're pretty small, but so are the particles in our atmosphere, the nitrogen and the oxygen. So they interact with those really small wavelengths. So the atmosphere creates friction, and the particles, blue visible light wave, gets blasted everywhere else. So this is our sky, right? So it appears blue to us, right? Because we just talked about the small wavelengths that keep hitting the particles of nitrogen and oxygen, those really small, lightweight particles on our periodic element that are in our atmosphere, right? So it looks blue. But there are 12 people who've been off of our planet, and they know what it looks like from what? That's right, the moon, right? So look at our planet. So this is in the daytime. What color is the sky? That's right, it's black, because black absorbs all of the colors. And so down there, the moon, it doesn't have an atmosphere. In fact, you could still see the footprint on the moon because there's no atmosphere on it. So look at that. That's Mars, right? So Mars is a little more yellow because its atmosphere is made up a lot of carbon dioxide. So it's making it look a lot different. Okay guys, we've learned a lot about light and color, our retina, things that are bouncing off our atmosphere, why the sky is blue. Oh my gosh, so much going on, right? Oh, that's right. So the reason that like stop signs and danger signs are red is because the longer the wavelength, we can see things from further away. If the wavelength is really, really long, we can see them further away in like if it's raining or it's misting. So danger signs, it's a good idea that we could see them from far away. Hey guys, so we've talked about what is light? What are waves? What's the frequency? What's our retina? Oh my gosh, why is the sky blue? We've learned a lot. So now when you walk around, know that there are all kinds of waves that you can't see and you're walking into them all the time. Think about the whole world, and what we'd like you to do is stay curious and keep on sciencing.